Today I'm going to show how to set up a generic box sliding down a hill dynamics problem. We're given a generic weight, a generic normal force, and we're going to use all that to solve for the force of friction. And you can see the slope of our incline is 24 horizontal to 7 vertical. So generally a problem solving strategy with this type of problem is to make the coordinate axes in the incline that you're working with. But as you can see, that creates a problem with the weight force downward is now out of line with the y-axis. And so we're going to have to use angles. This is something that is difficult to visualize, but you can use the angle of the incline to find the angle away from the y that the weight force is. So it's a little easier sometimes though to look at this in an upright position. So as you can see, the weight is now diagonal instead of completely upright, and our incline angle is now more or less a triangle with the hypotenuse on the x-axis. But if you've ever known anything about diamonds, you can see that a diamond is actually just a right triangle reflected about an axis. So if you have the sides on one of the triangles, you can reflect that exact same triangle across the axis and have the exact same side lengths on that. So we'll show that on this next diagram. So here's everything. It's a little bit more simplified. There's no box, there's no normal force or anything like that. We're not worried about that right now. So here's the slope of the incline, but reflected about the x-axis. So what you notice is that the weight force and the diamond share a common point. And whenever you rotate a shape about a common point, wherever its new axis is, the slopes on each side and the sides of the diamond are the same. So we can rotate this diamond to be in line to where the weight force vector is the bisecting axis of this diamond. So you'll see we did that here, and you can tell that we can now figure out which one is the horizontal and which one is the vertical. But in our problem, we had our axis tilted a little bit, so we'll show that here. And you can see that as one side of the triangle or one side of the diamond is not really helpful, but the other one, the 7 side of the triangle, is almost exactly parallel to the x-axis, and the 24 side of the triangle is almost exactly parallel to the y-axis. So if you're solving for that bottom angle, all you have to do is use sine and cosine relations to find the x and y components of the weight force.